Advanced Math Set 97, the ambiguous case. Okay, so this case is all about triangles, and when we look at a triangle, you can see that there are 6 parts. You have 3 angles and 3 sides. And you can solve for the entire triangle if you know one side and 2 other parts. So if you know one side and 2 other parts, you can solve for the entire thing. If you know one side and the angle opposite that side, then that's called a pair, and you can use the law of sines when solving for the triangle. So we are going to look at cases where you have a pair, or in other words, an angle and the side opposite, and then we'll talk about a couple of different options. So if you have one side and the angle opposite, and then you have another angle, you can then solve for the entire triangle. It's pretty easy, because if you have 2 angles, then you can find the third angle, because the first 2 angles, you just add them together, then subtract from 180 to get that third angle. And then from there, you can just use the law of sines to figure out the other side. So for example, if you have a equals 6, the side A equals 6, the angle A equals 30, and the angle B equals 70. It's easy to find the angle C because we know it has to be 80 degrees, because 30 plus 70 is 100, and we need 180 degrees total in the triangle. Then we know one side is 6. So from here we use the law of sines. So B over the sine of 70 is equal to 6 over the sine of 30. So B is equal to 6 sine of 70 over sine of 30, which is 11.28. So we know that the side B is 11.28 units long. Then we can use C over the sine of 80 equals 6 over the sine of 30. We're solving for C here. So C is equal to 6 sine of 80 divided by the sine of 30, which ends up being 11.82. So our triangle has 2 different lengths of sides. B is 11.28 and C is 11.82. So that was the easy case. Remember, we said one side and 2 parts can give you all of the triangles. So if you have one side and the angle opposite, which is a pair again, and then you have another side, it gets tricky because you can't draw a picture of it, first of all. And then there are some conditions in solving for the triangle. So if you have one pair, meaning the side and the angle opposite, and then the side of another side of a triangle, you can still solve it, but it's tricky. So we have one pair and one side. That is called the ambiguous case. So the first thing that you have to do when you have the ambiguous case is you have to figure out the height of your triangle. Figuring out the height of your triangle is going to help you figure out how you're going to solve this problem. So, for example, if you're given A is 40, side A is 4, and side C is 9, and just to draw the triangle and solve for the other values of the triangle, we know 2 of the lengths, but we're only going to draw one length for right now. So we know angle A is 40, and we can label angle A. Let's see, where is it? I'll just put it right here. We know angle A is 40. I'm going to back up just a little bit. So we know angle A is 40. And then we know that little c is 9, so side C is 9. So that means that this has to be B up here, and that C is going to be somewhere along this line down here. C is going to be down here somewhere. So that's the angle C. So that means that our length A is going to be somewhere over in this area or this area. So we'll just draw it right there for right now, and we're going to say that that has a length of 4. So we have to know the height of our triangle to move on from here, because that 4 can move up or down. It can kind of swing, and it depends on its relationship to the height. So we'll take a look at that example. So first of all, if that side is equal to the height, then you're going to have a right triangle, because the height and the length of the side are the same. If it's less than the height, then you run into a problem, because if you have a side that's less than the height of your triangle, you don't actually have a triangle because it's not long enough to make a triangle. It's kind of like if you are dropping a rope off of the side of the building, it's not long enough to reach the bottom, if that makes sense. So then we have the case that if your 4 is bigger than the height, and at this point I'm going to switch over from talking about it as 4 to talking about it as just a side A, because there are a couple of different possibilities here. So if that side A is bigger than your height, then you have a triangle that looks like this one, or a triangle that looks like this one, because A can be longer than your height. It can be to the left or to the right of your height. But there's still one other case, and that is if your A is longer than your initial side. If A is longer than 9, then you can get a triangle that looks like this. So with these two triangles on the right, A has to be smaller than 9, and with the triangle that's on the left on the bottom, A is going to be bigger than 9. With our specific example of 4 being bigger than your height, then you're dealing with these two triangles here on the far right. So hopefully that makes sense. It's kind of jumbled, but hopefully I made enough sense in that to make it a little bit clearer. So we're going to go back to that example. Given that A is 40 degrees, and the side A is 4 and the side C is 9, draw the triangle and solve for the values. So we're going to draw the triangle, or draw what we know of the triangle, and then we're going to solve for H. So H, since this is a right triangle, we know that the sine of 40 is equal to H over 9, or in other words, H is equal to 9 times the sine of 40, which is 5.79. So our height is 5.79. Now, we know that our side, that is side A, is only 4. And so it's shorter than your height. So in this case, we have a problem. It's too short, and it's too short to make a triangle. So the solution of this is that there is no triangle possible that fits that description. Now we'll do a different example of a triangle that does work. So it says draw the triangle and find the missing parts. A is 27 degrees, side A is 5, and side B is 7. So the first thing we'll do is we'll draw angle A, and then we're going to put, we know that side A is going to be over here somewhere. So if side A is over here somewhere, then side B is going to be next to angle A. So we'll label that B. So that means that angle B is down here somewhere, so then we will label C up on the top. From here, we're going to find our height. So our height is going to be, we know sine of 27 is height over 7, so H is 7 sine of 27, which is 3.18. Now, compare that to 5, which is our other side, and we can see that it's less than 5, and it's also less than 7. So in this case, we can draw our two options. Our two options are either going to be a triangle that looks like this, or, well, a triangle that has a side like this one, or a triangle that has a side like this one. So we have this purple triangle or this red triangle. So we'll do the first one, which is this triangle here. So we have filled in the sides that we know and the angle that we know, and we can use the law of sines to solve for the other parts. So we have 5 over the sine of 27 is equal to 7 over the sine of b. So sine of b is 7 sine of 27 over 5, which is 0.6356, and b has to be 39.46 degrees. So we know that b is 39.46 degrees, but we also know that there's another option. And none of the numbers are going to change here except for angle b. And in order to get angle b, all you have to do is subtract it from 180. So when we subtract 39.46 from 180, we get our other angle measure, which is 140.54. So here's our first triangle, and here's our second triangle. And our second triangle has the angle measure of 140.54. So we're not quite done yet because we have our two triangles. We have 2 of the angles and 2 of the sides, so we need our last angle and our last side. The angle is pretty easy to figure out because you just add those together and add the 2 angles together and subtract them from 180. So we end up with the angle of the first one is 113.54, and then we'll actually go ahead and solve for that missing side by using the law of sines. So c over sine of 113.54 is equal to 5 over the sine of 27. So c is equal to 5 sine of 113.54 over the sine of 27. So c is equal to 10.1. Now we'll do the same thing with the second triangle. 27 plus 140.54 is 167.54. We subtract that from 180 and we find that angle C is 12.46 degrees. Now we use the law of sines to figure out what C is. So we get C is equal to 5 sine 12.46 over sine of 27. C is equal to 2.38.